Today I'll be proving this unique property in linear algebra that y hat equals ut, or the projection of y onto u equals uty. Alright, and it's a pretty simple proof. I figured this out within maybe 10 minutes or 5 minutes, but okay. Sorry for bragging. Okay, so let's decompose y. Oh, and before we start, we need to assume that u equals the identity matrix. Hopefully you've seen the proof of this and know this to be true. Okay, now let's break y into its components. So y hat plus z. Now, since y hat is the projection of y onto u, y hat is a linear combination of u. So we can rewrite this as, okay, and let's further suppose that these are the columns of u, and it's an m times n matrix, so I'll have n columns. So this represents each column in order of u. So this can be rewritten as a linear combination. So c1u1 plus c2u2, where c1 and c2 are constants, plus cnun plus z. And remember, z is orthogonal to u. So quickly you can see that z will actually cancel out. I'll show you. So u transpose times z is just u dot z. But we assume z is orthogonal to u, so this would just be 0. Right? If z is orthogonal to u, then u dot z would be equal 0. So let's multiply things. uty equals uut parentheses c1u1 plus c2u2 plus cnun plus uutz. Now, ut times z is just u dot z, and z is orthogonal to u. So this term here just becomes 0. Still not focusing? Alright. So this becomes 0, and finally we're left with this. But look, I want to distribute ut among these columns. So we get this. Remember, c1 is just a constant, so we can put this in front of the constant, all right? Okay. This 0 has nothing to do with this. Okay. Now, I want you to know something. Look, u equals I, right? Then that means ut columns of u1, u2, un would equal e1, e2, en. Hopefully you know why, because this is the identity or unit vector that make up an identity matrix. So, yep. So utu1 would just be e1. Hopefully you understand why. So uuty would equal, oh, never mind, this equal sign shouldn't be there. Ignore the u times the parentheses. So we get u c1e1 plus c2e2 plus cnen. Okay? And something you should notice here is that if e1 equals 1, 0, 0, then that means you can easily see that uty would equal u c1, c2, cn. Okay? Because we multiply c1 by this identity vector, and we keep on multiplying, and then we get this. Let me see if I made any mistakes. No, I don't think I made any mistakes, did I? Did I make any mistakes? No, I don't think I made any mistakes. Okay, so remember that U can be broken up into this. U1, U2, UN, multiplied by this matrix right here. C1, C2, Cn. And you can see by multiplication rule of matrices, this just ends up being C1, U1 plus, oh, this should look familiar, right? Cn, UN. This equals the linear combination of y hat. Y hat equals this part. So this just equals y hat. But look what this also equals. It equals u, ut, y. So the projection of y onto u just equals this, if the columns are orthonormal. So let me rewrite it. U, T, Y, Q, E, D. Comment down below if you think I've made any mistakes. I think I've just realized maybe the dimensions of the matrix were wrong. I don't know. I think this is correct. See ya.